So Himanshu, how do you want to do this? There are people waiting in the lobby. You have to let them in. I'm seeing names. Someone is waiting. Api, Himanshu, you're letting people in, na?
Yeah.
Okay.
I think we should start now, and I think there will be.
Yeah, I think so.
Yes.
Slowly and slowly, people will come and
Yeah.
join. Should we?
Yes. Sir.
Good evening, everyone. Myself is PRAMENDRA. Today is the second day of webinar organized by IAPT RC19. Am I audible, Himanshu?
Yes, sir.
Today our resource person is Professor Pramendra Kumar Vajpayee. I feel privileged to introduce Honorable Vice Chancellor Sir, Professor P.K. Vajpayee Sir, JP University Chhapra. Sir is excellent academician as well as administrator. As physicist, he is internationally known and he did a lot of research work in the field of solid state physics, quantum mechanics, biophysics, and almost all fields of the physics. Having more than 260 research papers, written several books, and several research projects were completed as principal investigator. Personally, during last 2.5 months interaction with him, I found him excellent physicist, excellent teacher, excellent administrator, and overall excellent human being. Sir, be member of IAPT RC19 is organized our Quantum Fest week from 10th of April to 15th of April on online mode, and later on we will organize it for a week offline mode. And we are very much thankful you have given your precious time for the today's webinar. Thank you, sir. Thank you very much.
Should I start?
Yes, sir.
Yes,
Please.
So at the outset, let me, from the bottom of my heart, thank Professor Vijay Singh and Professor Pramendra Singh and all members of IAPT RC Bihar who have been kind enough to provide me this opportunity to discuss the wonderful world of quantum physics. Today, we will have the opportunity of traversing through it and discuss among us some of the fascinating aspects of science in 21st century, utilizing the core concepts of quantum mechanics. I shall share the PPT. I thought there will be a lot of mixed audience and students of various colleges, and therefore instead of talking the notional things as the applications of quantum physics in 21st century in very diverse area, I thought it will be proper to have a PPT. And frankly speaking, I enjoy making PPT and doing physics, which I hardly get time. The topic that I have chosen, I have slightly changed it. Yesterday, when I got the news of Peter Higgs, he expired day before yesterday. So I thought, let me introduce some aspects of Peter Higgs and the standard model in the talk. एक तरह से ये श्रद्धांजलि होगी पीटर हिग्स को to discuss about Higgs boson and the role of Higgs boson in understanding the nature of reality, especially how the mass is introduced in the elementary particle. So some of the slides I have included just for Peter Higgs. there is a positive news also. The accelerator that we established in Bilaspur, the only 3 MB high current accelerator in the country. Day before yesterday, we also got the permission from Atomic Energy Research Board, AERB, to conduct the experiment on that accelerator. So one, the sad demise of Peter Higgs, a bad news, and another very encouraging news of another accelerator joining the bandwagon of matter radiation interaction research in the country. So with this small introduction, I share my slide. I think it is visible.
Yes, sir.
Yes.
Yes, sir. Yes, sir.
So I will not go into the slide mode. Otherwise, what happens, we don't understand when the slide is not working. Okay. So the topic of today's discussion is quantum physics driving 21st century technologies. And I start with some of the famous quotes on quantum physics or science as such. Werner Heisenberg once said, what we observed is not nature itself, but nature exposed to our method of questioning. Albert Einstein said, people like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. Karl Popper, the famous social scientist, he said, science may be described as the art of systematic oversimplification. Similarly, the Max Planck also said, there is no matter as such. All matter originates and exists only by virtue of a force. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter. And Niels Bohr said, how wonderful that we have met with a paradox. Now we have some hope of making progress. And finally, John A. Wheeler said, someday we all understand the whole thing as one single marvelous vision that will seem so overwhelmingly simple and beautiful that we may say to each other, oh, how could we have been so stupid for so long? How could it have been otherwise? Why I selected these quotes and started my discussion, my talk with these quotes, is actually quantum physics none of us understands. We try to apply it, and therefore any efforts of understanding the nature of reality makes us in oblivion. The important beauty of quantum physics is its application is wonderful, it is simple, and it is fascinating. With this simple background, let us try to understand the evolution of modern science and technology. I will make it very simple. अगर आप लोगों में से कुछ लोगों को ये लगता हो कि अंग्रेजी में दिक्कत है तो मैं बीच बीच में हिंदी बोलूंगा, मुझे नहीं पता है, द नेचर ऑफ ऑडियंस. अगर आप देखें डेकार्टियन साइंस का जो इवोल्यूशन है, इफ वी स्टार्ट विद द एम्पिरिसिज्म एंड डिस्कस द साइंटिफिक मेथड, then we understand that the modern science and technology, with the introduction of logic and the observation, the scientific method became a wonderful thing to reach the truth. And it has changed dramatically our perception about the universe, about the world. We also know as the science progressed, the terrestrial and celestial world, they became together. However, one of the unfortunate thing with the evolution of the modern science and technology has been we understood in sections, in pieces, by dissecting, by analyzing the individual component. So the dissecting physics or dissecting science, dissecting nature has become the almost the essential component of scientific inquiry. Another important concept that was evolved with the Descartesian science was the observer being passive. Any inquiry the observer was not considered, the role of observer was not there. It all changed, which we call the Great Revolution in the beginning of 20th century. And this, there was a paradigm change by two important additions in our knowledge. One is the theory of relativity, another is quantum mechanics. And it has changed the complete worldview. The occasion that you are celebrating, Quantum Festival or Quantum Fest, it is nothing but the journey of understanding this revolution, trying to understand how this revolution is still shaking the worldview, and how in the 21st century, the relevance of this of knowledge can be extended and applied to those areas which we never thought will be applicable in this field. As I said, understanding of universe and understanding of reality was changed with a scientific revolution which has resulted into two strong theories. One is the Einstein theory of special relativity in 1905 and general relativity in 1950. This theory made very strong impact on our understanding of the universe. And the major impact was that the observer was no longer external to the phenomenon. Another important thing, and this has resulted, as we all know, the inertial frame and the frame of reference and the relativity effect and all those things, which we will not go into the detail. Another important thing was the Young's double slit experiment that was used to understand the wave nature. It was applied a number of times in science during that time on photons, on single electron, and now on macromolecules. And this single experiment's repetition has confirmed. And this is a very important change in the physics, that observation and interpretation. Summarily, you can call it human consciousness. It is instrumental in the manifestation of wave-particle duality. It is not the measurement per se. This change in the perception, bringing the observer at the center, the perturbation in the central, very essential part of understanding reality. This was the change which we call the introducing quantum regime. Now, these two resolutions that drastically modified the foundations and ushered in profound socio-economic changes. And this revolution was not done in one way. It was done in two different, seemingly different streams, which we now know as the Schrodinger wave mechanics and the Heisenberg matrix mechanics. Both these branches of quantum mechanics, they seem to be simply different mathematics. But if you see on the ontological aspects, on the epistemological aspect, if you see the quantum mechanics के अगर तत्व ज्ञान को हम जानना चाहें, जिसको जानने की कोशिश बहुत कम हुई है, क्वांटम मैकेनिक्स का एप्लीकेशन ज्यादातर हुआ है using the mathematical structure that we have developed over a period of time. But the real quantum structure, what it is, what is the nature of universe, and what is the nature of reality that we perceive, both these questions remain debatable even today. As we know, कोई भी क्रांति होती है तो उसकी जो इफेक्ट होते हैं वो लॉन्ग रेंज होते हैं. Similarly, this scientific revolution, which we call quantum physics, it has long range effect, and that are so radical that we have never realized at the time of the birth and evolution of quantum mechanics. And we will say during this discourse that the development that are occurring even in 21st century or in the second half of the 20th century. I don't know what is this here. They are so different that we never understood that quantum mechanics will be used for this purpose. For example, what is this here? How quantum mechanics is now helping the new management approaches. Nobody could have thought in 20th century that leadership grooming or quantum leadership will be a very strong subject, which is now the focus of the management strategy in management aspects. Similarly, the seemingly different quantum mechanics, as I said, almost the same time, Heisenberg developed the matrix mechanics, Schrodinger developed the wave mechanics, and the Dirac ultimately developed the direct equation that could intrinsically explain the spin of electron. Yesterday, I could not listen the beautiful talk of Professor Singh on electron spin. But the beauty of Dirac equation could be understood that how he conceived the whole mathematics through which we develop the intrinsic properties of electron and develop the spin as a intrinsic property. And therefore, the evolution of quantum mechanics, if you see, has not been only the mathematical structural changes, rather understanding of the physical reality of universe. And therefore, it could be connected on one hand towards the standard model and the cosmology, on the other hand towards the astrophysics. And this expansion has led to the evolution of universe. And now the association of information with the matter and energy, it has become the new evolutionary universe that we are that we shall be discussing at the end, as one of the important 21st century technology that may bring a revolution in the cultural human race. We will discuss it a little later. Now, forget about the 21st century. Let us go back to the 20th century in the first half. As soon as by 1930 or so, the quantum mechanics theoretical background was developed, there have been enormous applications. And the way science has changed during that time, one can say without any exaggeration that quantum mechanics has changed the world. And some of the things that must be mentioned is development of quantum electrodynamics, invention of transistor. This invention has changed the societal view, and we have now seen the digital societies. It is due to that initiation, that particular development, that has led to the whole electronic evolution and later on the communication evolution. In addition to this, the 5 fields that have been developed, the particle physics or high energy physics, the astrophysics, nuclear physics, and now what we call condensed matter physics or the nanotechnology. This is all due to the quantum revolution that we are enjoying as the quantum field. Now, if you see the second half of the 20th century, in the first half of my talk, I shall be developing the basis for the students so that they can understand the evolution of physics and its integration with the quantum ideas, and we can appreciate then how each traits of quantum mechanics are the driving force of the newer technologies that are coming up in the 21st century. I will take 3 or 4 examples and shall discuss how critical the basic understanding of quantum ideas and quantum physics is even today in order to drive the technological development of the world in the right direction. If you see the second half of 20th century, we call it normal science, or some people call it age of consolidation of physics. Thomas Kuhn called it normal science, and if you see the structure of scientific revolution, which was published in 1962, he has discussed that this was the very important age, 1950 to 2000. It has been an age where many concepts of quantum mechanics, they were maturized, they were understood, they were analyzed, applied, and various branches of science, which we call various kinds of physics, they were mature to understand the truth in various areas. Now, before we make it further, we want to offer our Shraddhanjali. We want to salute Peter Higgs, who expired day before yesterday. He was one of the most celebrated scientists, and verification of the existence of Higgs boson by Large Hadron Collider in 2012, we can call it as one of the most celebrated event in physics during the last decade, as it confirmed the theoretical prediction made in 1964 about the Higgs boson. Now, many people talk about the Higgs boson as the God particle, this and that. So this generation, even at the very young age, they should understood what is the contribution of Peter Higgs, why the Higgs boson was so important in the overall theoretical structure of universe and in the development of high energy physics. High energy physics is one of the areas that has developed so fast. It was introduced by the Murray-Gell-Mann, and Gell-Mann introduced a particle called quark. It was theorized in 1964 by Gell-Mann and George Wigg. The whole idea of quark was very, very different from the hadrons that we were knowing at that time, the electron and proton having the integral charge. And it was mesmerizing to know that these quarks were assigned fractional charges. And according to this theory, the hadron, which represents the strong interactions, they are made up of 2 or 3 types of quarks. These are called up, down, string, and they have the electric charges like 2/3, 1/3. And for example, a proton is made up of 2 u quark and 1 d quark, while a neutron consists of 2 d quark and 1 u quark. And therefore, all hadrons were conceived as the composite structures. Since then, many other quarks were proposed, like charm, 1974 it was proposed, bottom 1977, and top ultimately in 1995. What is important by predicting these quarks, that they were also associated with flavor, and they were also associated with colors. So they had a number of varieties in terms of flavor. They have number of types in terms of color. They were called green, blue, yellow, and so on. It has nothing to do with colors. Moreover, each quark, an anti-quark was conceived. And quark were considered colored, whereas hadron were considered white. So one particular aspect was that colored objectives are confined. They are associated in forming the hadrons. They cannot be free. You cannot observe a free quark. Now, problem was that if a quark is to remain confined, there has to be a force among them that differ considerably from the electromagnetic forces or other forces, the big forces. And then Gell-Mann proposed in 1995, just as the electromagnetic force among electrons is measured by the virtual exchange of photons, quarks are linked to each other by a force arising from the exchange of other type of quanta. They call it gluons, in order to stick the quarks together to form observable hadrons. And this proposition led to a very good explanation of the strong interaction. Today we call it quantum chromodynamics. So we have the explanation of weak interaction in terms of the electromagnetic interaction in terms of the quantum electrodynamics. We have the explanation of strong interaction in terms of the quantum chromodynamics. And therefore, quantum chromodynamics became a very interesting evolution of quantum mechanics to describe the strong interactions. So far, quantum electrodynamics and quantum chromodynamics became quantum theories of electromagnetic and strong interactions. Now, there was a third interaction called weak interaction. There were theories, many theories of weak interaction, even before the Weinberg and Salam put forward independently the theory of weak interaction, respectively in 1967 and 1968. And they unified the electromagnetic and weak interaction. Now, this model taken the idea from the Glassow's 1960 paper, and therefore Weinberg, Salam and Glassow, they got the Nobel Prize in 1979 when the CERN experimentally predicted one of the prediction of this theory, that is the existence of weak neutral currents. So this what we call now grand unification theory. It unified the weak interaction, the electromagnetic interaction and strong interaction ultimately in 1974 by Howard Georgi and Sheldon Glassow. This story is known as standard model in understanding the nature of universe. Now this standard model is no longer standard, as there are some problem in this model. I'll discuss little later after 1 or 2 slides, and the role of Peter Higgs in making it complete. In between, we must understand the Bohemian mechanics. There was parallel interpretation of science, which included, if I quote the Bohm and Hilly's paper, in which they concluded that the implication of non-local connections. Now it seems slightly disconnected. The quantum mechanics nature, when we discuss little later, it has the non-local connection. Non-local connection means it has a property which is called entanglement. The quantum states describing the particle in universe, they are such that the two particles, if they are entangled, if there is a change in one particle, the second particle will experience the same change immediately. This property of quantum mechanics, this is called non-local collector. And this non-local connections are that objective reality itself is entirely a construct of the human brain. This was the Bohemian mechanics. It's a wonderful idea that what we are seeing as the reality, it is the construct of the human brain. The reality is not like that. We will discuss more about it. The true nature of reality hidden from us. So how to find out it? And another important aspect of Bohemian mechanics is our brain. It operates as a holographic instrument. So it operates as a holographic frequency analyzer, decoding projections from an underlying more fundamental dimension. So what we are seeing is the projection of the reality at a particular time, not the objective reality. Bohm concluded that even space and time represent constructs of the human brain and probably may not exist as we perceive them. This particular idea, which was developed in 1980s, it is now coming up again in terms of the information being the central to the universal reality. We will discuss about it little later. One more comment is important here, that the role of material aspects in the construction of reality became an issue of concern. And in fact, for many scientists, it even grew to a central theme in the understanding of nature. That whether material exists or whether material is an illusion. And it combines with the Indian thoughts of ancient time so closely that one gets mesmerized when you try to compare the analogies between the Bohemian mechanics and the Vedantic thoughts of duality. Bohm believes that randomness is nothing but an order. As we see the order out of chaos, he simply said that the randomness contains hidden order. And we perceive this order as the randomness because our limited understanding of the complexity of the processes involved. So there has to be the new methods of finding the objective reality and how to remove the virtual reality or how to, जिसको कहते हैं ना, माया का आवरण कैसे हटाया जाए ताकि हम real scientific universe को देख सके. We will see how this is being developed. Now, let us try to understand what is non-locality. Now, this non-locality has been regarded as a very curious property of quantum physics for a very long time. And there was one concept that only it is seen in the micro scale, in the quantum scale. As soon as you come to the macro scale, there is no non-locality. The things becomes localized. This was slightly perturbed in 1982 when Alan Aspect and his team, they did the experiment that was proposed long back by Einstein, Podolsky and Rosen in 1935. What Aspect did, he created photons by heating the calcium atoms with a laser, and then the two photons were manipulated to travel in the opposite directions. What he discovered that the polarization of one photon at a marked distance immediately polarized the other photon, just as quantum theory in the non-local properties or in the entanglement predicted. So in 1982, he in a way experimentally proved the entanglement properties of quantum states. What is the epistemology of it? इसका तत्व ज्ञान क्या है? इसकी विवेचना क्या है? इसका मतलब है कि फोटॉन somehow एक दूसरे को कम्युनिकेट कर रहे हैं और वो एक दूसरे को अपने कोरिलेटेड स्टेट के बारे में बताते हैं, no matter how distant they are. This is very important. No matter how distant they are. Distance इसमें important नहीं है. Till they are entangled, they are able to change their properties according to others. This is a very important thing. And therefore, non-local connection seems to exist between these elementary particles और जो सेपरेशन है उनके बीच में, जो हम स्पेस का सेपरेशन देख रहे हैं या जो टाइम का सेपरेशन देख रहे हैं, it is just an illusion. Now, this is the new conceptual understanding about the space-time realities in the quantum world. Now, there are two important questions that emerged and that must be answered. The first question that emerged from this discussion is, it is evidently of major importance to establish if non-locality is also a fundamental feature of nature at macroscope. At micro scale, they have already proven it. But whether this remains a fundamental feature of nature even at macroscope, and if at macro scale it remains the fundamental feature, then is it possible to understand the complex structure of central nervous system or in a way neurology using these known local connections of quantum states? This is one of the roadmap is for the neurophysics people and the quantum. Another question that comes, whether the brain interacts non-locally with an universal knowledge domain or in the Bohemian terms, an implicate order. Bohemian mechanics considers two types of order, implicit order and explicit order. So the question is whether the non-local character of the states is responsible for the universal interaction of the brain, or whether it is the change in the order, objective reality and the virtual reality. These are the two important holistic questions that are not yet answered by the quantum people. Another important thing, as I missed it was very important to discuss this objective reality. Now we come back to the standard model. As I said, the total framework that was developed by the Gell-Mann in terms of the high energy physics and constituted the theoretical framework for understanding what nature is made of, and it turned out to have extraordinary predictive capacities. The so-called standard model has three ideas. Now these three ideas, first idea is nature of particles. All particles forming the universe can be separated into two categories, bosons and fermions, having the different characters of spins and different statistics to predict their property. The second idea was all elementary particles that make up the whole universe, they are of three types: the electron family, the quark family, and the neutrino family. The third idea was all four basic forces that have been united, except gravitation that has not yet been united, they have their own quanta associated with the fields. So the nature is the field, rest is the illusion. And these fields are represented by, say for example, photon for electromagnetic interaction, Z and W bosons for weak interaction, gluons for a strong interaction, and recently discovered, not yet confirmed, gravitons for gravitational interactions. The LIGO experiments has confirmed the gravitational waves, but the gravitons has not yet confirmed. So this is the whole theoretical structure of the physics that has been discovered by the entry of the so-called quantum fest or the quantum world. With this, what we can learn. Now this wave particle duality, as I have already discussed, this is not simply the wave particle duality. We do not know the reflection of nature in the perceived reality, which sometimes demonstrated as wave, sometimes demonstrated as particle, whether it is reality or wave and particle nature of the objective reality is the reflection of illusion. This is the question now that comes in physics very importantly, and the moment you think of it from the ontology point of view, it matches you with the Vedantic theories. I will not go into the detail of that, but there is a deep connection between what nature has. What is the meaning of wave packet? What is the meaning of wave function? We still don't know. We simply know that if you have the wave function, you know the information about that particle. You know the mathematics, how to get this information. You know the Schrodinger equation, how to solve it. You know how in different potentials, the particle property changes. You know from the Heisenberg mechanics that there are operators that can change the dimensions, but what is the meaning of this so-called infinite vector space, the Hilbert space that you call? How it spans the wave functions? What is the meaning of physical meaning of n-dimensional space, and how this n-dimensional space is projecting into different projections in different dimensions, and what is the physical meaning of it? It still remains perceived, non-understood. Another important thing is that when we talk of Planck basic proposition of energy quanta, now what exactly it means? Whether the Einstein quanta of photons and Planck quanta of energy in the molecules, it has the same meaning, or it has the different meaning. These questions can be summarized in terms of the quantum theory, which predicts that any particle, especially we talk of in terms of electrons, that it has the energy levels that are quantized. Now, these energy levels, for our limited understanding, we say that when it gets the energy, it absorbs it. When it is in the excited state, it emits it. And during these transitions from one level to another level, they exchange the quanta of electromagnetic radiation we call photon. Now, this is a simplistic mechanism. This is not the understanding of reality. And therefore, particle, when they exchange energy, now the real question comes. When I was doing the biophoton research on the living state in 1990s, and we were doing the experiments of what happens when the various life process like autocatalysis, like the breaking of the photosynthetic pathways, like DNA folding and unfolding when it occurs. Why actually the photon emission rate changes? These biophotonic emission rays, are they connected with the quantum communication? Similar question comes here, that the exchange of energy between the different atomic transitions, whether they are the demonstration of the quantum communication or they are simply the energy exchange processes. This could not be understood properly while we were discussing the atomic interaction in terms of the quantum understanding. Now, let us close the standard model with the final statement that Peter Higgs gave a theoretical prediction of Higgs boson, which we now popularly call God particle, which solved one of the fundamental problem of a standard model. A standard model had a problem that it could not explain the origin of the masses of elementary particle appearing therein, called for the existence, and it called for the existence of a new particle, which has to be a boson, whose associated fold will permeate all space. Now, the existence of such a boson was predicted, and just a consequence, it may be, जैसे कहते हैं ना, संयोग होगा ये कि एक ही सन में एक ही जर्नल में 3 आर्टिकल पब्लिश हुए. 1964, the first article was the journal was PRL, and the first article was by Peter Higgs. The second was by Frank Engel and Robert Brown, and the third was Gerald Guralnick, Carl Hagen, and Thomas Kibble. All the 3 articles, they predicted the Higgs boson in order to make the standard model a stable theoretical framework. And as I said, when in 2012, in the Large Hadron Collider, they declared that the Higgs boson existence is proved, it was one of the celebrated events in physics because of this reason. And today, we pay our homage to Peter Higgs, who expired, and हम ईश्वर से प्रार्थना करते हैं कि उनकी आत्मा को शांति दे. उन्होंने फिजिक्स के लिए जो कंट्रीब्यूशन किया है और एक जो नेचर का थ्योरेटिकल फ्रेमवर्क हमारा अधूरा था, उसको समझने में जो मदद की है, वो मुझे लगता है कि जब तक साइंस और टेक्नोलॉजी रहेगी, तब तक पीटर हिग्स को याद किया जाएगा. As we all know, this was not possible simply by theoretical framework, and we must appreciate the efforts of experimentalists in science that drive the technology together. This is one instance, as I'm an experimentalist, and I have also established one accelerator by devoting my 7 years simply in its establishment. One should appreciate how the technology develops when we try to execute the or predictive values of standard theoretical framework. when they are executed in the experimental framework, how difficult it has been. And one can understand, especially the young students, they should understand that when in 1994, Sun approved the construction of LSC, which is today the world largest particle accelerator, और इसकी रिंग 27 किलोमीटर की है, जिसमें 9600 मैग्नेट्स हैं अलग अलग तरह के, और इनमें से 1200 टू पोल सेमीकंडक्टर मैग्नेट्स हैं जिनको की मेंटेन करने के लिए, जिन लोगों के पास 300 मेगाहर्ट्ज से ऊपर का एनएमआर है और जो सुपर कंडक्टिंग मैग्नेट्स केवल एक मैग्नेट को सस्टेन करते हैं, वो जानते हैं कितना डिफिकल्ट है हीलियम को, लिक्विड हीलियम को लाना, भरना और मेंटेन करना। ये मेंटेन रहती है -217.3 डिग्री सेंटीग्रेड पर 365 दिन, जब से बना है ये एक्सेलरेटर आज तक, बिना किसी डिसकंटिन्यूएशन के। और ये जो 217.3 डिग्री सेंटीग्रेड टेम्परेचर है माइनस में, ये आउटर स्पेस से बिलो टेम्परेचर। So you can understand the kind of low temperature technology that is involved, the kind of precision developing the magnets that are involved, the kind of cavities that are involved. And many of you may be, it may be a pleasant surprise that many of the magnets and cavities are supplied by India. So the Indian scientists are doing wonderful job. Only thing, we are not connected with each other. We are not understanding the developments in various areas that is going on. Now, another thing, inside that ring, guided by the magnetic field, as we all know that the beams are guided by the magnetic field, we can also guide the beam linearly by the electric field called ESA, electrostatic analyzers, and the magnetic field, they curve the beams. So two beams of protons, they are accelerating in their own ring. People have the perception that both the beams are coming in the opposite direction and colliding. No, they are running in the opposite direction in two rings, and when they get the sufficient energy, they are allowed to collide. And as a result, as we know, that they have the number of detectors, the Atlas, CMS, LIS, LCHB, and so on. And they are developing these detectors and developing the electronics, developing the software for them. It is another advanced science and advanced technologies that is developed by the hardcore physicists in different international labs. So this is another opportunity to our young students that physics as a career, not only in physics, but learning and advancing most of the technologies, especially in the communication technologies and computer technology. Most of them are initially developed by physicists, including the internet. As we all know now, it's a history. The first collision was in 2010. It produced the 7 tera electron volt, the highest energy. Then finally on July 4, 2012, Sun publicly announced that they have detected the Higgs boson. So we all know now that Peter Higgs got the 2013 Nobel Prize and so on. एक चैलेंज भी आया, चैलेंज ये आया कि 2013 में LSC का ऑपरेशन बंद कर दिया गया क्योंकि they wanted to attain the 13 TeV energy, and there were certain corrections that were made. For 5 years it remained closed, and again on April 12, 2018 it began its new stage. और जब ये दोबारा प्रोटॉन कोलिजन टेस्ट हुए, they got the unexpected data which predicted the new laws of physics. It is still not confirmed, but standard model so far is working very well, but it is not the final theory of physics. Any day, any time we may see evidence against this model, and we will have the chance of developing the new theoretical framework, again developing the new experimental framework. Unfortunately, the kind of energies that are required to break that barrier is so high around, this is 13 TeV, we require around 1500 TeV. So it is not possible on Earth to reach those energies and develop the accelerator of that kind, but certainly the kind of space research that we are doing, we may get such conditions where such predictions can be applied, executed, and confirmed. And therefore, there is always a chance of doing the new experiments, confirming the new results, and predicting and confirming the new theories. Now, to summarize it, at micro level quantum world, the network of elementary particle has the ability. The young students, they should listen it very carefully. This is the new interpretation of quantum particle ensembles. These elementary particle has the ability to store information. How? By perturbation of the wave function that belongs to the particles. How this can be perturbed? Through modalities of either position, spin, charge, and polarization of a particle. So these are the parameters. This is the trick which has to be done. And if those who are doing the experimental physics, in last decade, most of the efforts in the field of spintronics and in the field of multifunctional material has been to develop the type 2 multiferroic material by using this kind of perturbation. This has been the whole effort. Now, according to the quantum theory that we have developed so far, such interactions between particles can be described as wave interferences, producing noble vibration. We know that even in the classical waves, the vibrational modes can be produced by dancing the various vibrations in phases. Now, thus, these interactions can be tuned and the wave interferences can be controlled so as to produce novel vibrational patterns in the form of superposition. And you know, this superposition is one of the important properties of quantum states that can be used in various techniques, as we will be discussing slightly later. Second important thing, matter at its most basic level may exist as a system of vibrational patterns in a wave of mutual relations. इसको हम कहते हैं स्ट्रिंग थ्योरी. इस स्ट्रिंग थ्योरी को जब आप स्टैंडर्ड मॉडल से आगे ले जाते हो, you see that the whole universe becomes सूर्य रश्मि. वेदों में एक जगह आता है कि हम कहां से पैदा हुए, सडनली सूर्य रश्मियां हुई. Another important thing, that the quantum systems are adaptive systems, complex systems, not the linear system. They are the non-linear system. And the apparent randomness or chaos in the quantum system is the hidden processes that are not understood so far. And therefore, what we can conclude in the first part of the talk, that in spite of impressive insights through quantum physics, the very nature of universe is presently not well understood and requires further investigation. But what is understood, how it can be used. This is the second part that we will be taking. In order to apply anything, we have to understand the basic parameters or the traits of a system which we are going to use. So the first thing that we will be understanding is the characteristics of quantum world. What are the basic parameters by which we can modify these quantum systems? And the most important characteristics is not that entanglement is the most important characteristics. Since I am going to use entanglement in my the application that I have chosen, so others I am not explaining in detail. The intrinsic connectedness, which is known as entanglement, is the basic characteristics of quantum states. How these are the two states which are together. in the time-space field. Now, after traveling, they remain connected. This is what is entanglement. This space you can increase, this time you can increase. It doesn't matter. So, the important aspect of entanglement is they communicate. They are correlated. The communication between these two paired particles, and this communication is defined in terms of the common properties. So common properties remain same whether they are distant in space, whether they are distant in time. And this occurs over a very long distances without any loss of time. If one changes the property, other changes the property immediately. And I will show that it has been proved at least for 7,000 kilometers in a recent experiment in China. Now, this is the non-locality in quantum mechanics, which is predicted by Bell in 1966. Entanglement is supposed to represent a correlation of particle properties within a hidden information field. Now, this is a new postulate. We do not still know, but in the information-centric world, this is what is considered as a postulate or a hypothesis that this from where the correlation comes. They are saying that is due to there is some field of information coming from either the past or from the distant future in terms of the past, present, and future of time, which correlates these particles. This is yet to be understood. But this is the most important property used today for various kinds of application, including the quantum computation and quantum communication. Quantum cryptography, I will discuss all the three. Another important thing is quantum uncertainty. We all know very well that it is this uncertainty that makes the nature unpredictable. The predictivity has various outcomes. Many people think that the quantum mechanics is probabilistic, so it is less reliable. Not that. The events cannot be predicted. The outcomes may be many. And this property of the quantum states is again used. The superposition is again a wonderful property that is used in quantum computation to make it much faster than the classical computation. The whole idea is, say for example, superposition means if I have a two states, the combination of these states is also another state. Now this particular property can be used in computation where we can get simultaneously a number of bits called the quantum bits, which can be used for parallel processing of information, thus improving the fastness of computation. And this is the basis of quantum computation. We already discussed the wave interference. We know that the nature has wave particle duality, and finally the coherence. These are the basic properties of quantum systems that can be exploited to utilize in 21st century in various areas. Some of the usages, I don't know how much time I have. I still have more time. I have an hour. No?
You can conclude in 5 minutes, 10 minutes time.
In how many minutes?
5-10 minutes time.
Okay, sir. I will just show the applications of these things. The first application is quantum physics can create future fit leaders. I have given the reference. It's a wonderful article one should read. You know that leaders today has to manage very rapidly changing situations. They have to take the decision within the ambiguities in a nonlinear, multidisciplinary, in a network or interactive environment. And therefore, the current management approaches, they train leaders for processes that draw decision on certainty and predictability. The management theories that have been developed so far, they are basically the linear theories of physics, similar models, the predictable models, the so-called PERT analysis, and so on. And therefore, whenever they come across such type of situations, they are unable to take right decision. So in the field of management, they are exactly at the crossroad where physics was during the Newtonian era. And therefore, there is a chance for management people to develop the strategies so as to create future fit leaders using the idea from quantum physics. How these ideas are getting changed. Now, first let us understand in quantum theory how we take the decision or how we get the information of the complex systems. It is based on advanced culminated in massive progression in technology that can accommodate the complexity and uncertainty. These are the two things. Quantum systems are complex in terms of the interactions, and they cannot be predicted because they have the inherent uncertainty. Now, exactly the same analogy is there. What we have to do, we already have the quantum models of predicting the nature. The only thing we have to do, we have to take a step and extend these models and apply them for human behavior. That's all. So the models that are already validated for nature, they are to be extended for human behavior. And once we understand these models for human behavior, leadership is one of the human behavior. And therefore, these mathematical models allow for improved scenario and forecasting. They are therefore very useful in vastly improving decision making. There is an article by Adam Hall, wonderful article, how this can be implemented. We don't have time, otherwise we would have discussed it. Another branch of management, that is quantum leadership. This is a newly created branch. Study of natural phenomena, we all know, that have provided basis to study human behavior, and now people are extended it for leadership. Now, one particular example that Brian Orthel and Geoffrey West, they have defined a system where they call the complex adaptive system as the social system. And complex adaptive systems are nothing but the nonlinear quantum system. So we already have the models for these systems. That means the human social systems or the human behavior can be understood by the quantum mechanical system directly. And using these models, the Geoffrey West has developed a branch of management called quantum leadership. It is a new management approach that integrates the most effective attributes of traditional leadership with recent advances in quantum physics and neuroscience. And just to give you the they have taken 12 parameters, and these 12 parameters are included in a complex adaptive system, and they have developed what is known as quantum organizations. So the behavior of quantum organizations has been predicted in terms of the outcomes, probabilities, and these outcomes have been able to provide that difference between the traditional leadership training and the quantum leadership training is enormous. Some of the practical differences that quantum leadership is informed by quantum thinking and guided by defining principle of quantum physics. This is a new area for quantum physicists to connect with the management people and develop these type of training program in India. Quantum leaders think ahead by formulating many scenarios. As we know that quantum systems has the superposition, they have the different outcomes. So the quantum leadership tells you what are the different possible scenarios for a single particular event, encourage questions and experiments, and thrives on uncertainty. Quantum leaders are guided by the same principles that inform complex adaptive systems. They operate effectively outside the direct control of formal system. So adaptability comes naturally in them. They have the ability to reframe challenges, issue within the context of the environment and develop new approaches through relationships. Now, this is a completely new concept where quantum theories can be of great help. Only thing we have to learn the management technology and the vocabulary and adapt these theories into management. As we know that World Economic Forum estimates that digital transformation has created a change in the job market. Now, almost 1/3 of the job globally in the next decade, they are going to transform towards the digitally skilled people. And this trend will hit our countries, like developing countries, much more than the developed countries. And therefore, we have to change ourselves for new pedagogies, new curriculum, and new evaluation method, so as to not only discuss, understand the adaptive complex system and the digital societies and their needs in terms of the quantum systems. This is what has to be done urgently. Another change in the 21st century is the changing role of physics in interdisciplinary world. I don't know whether, please tell me, I have a number of examples that I'm going to show, but if you don't have time, I will stop after showing 1 or 2 examples.
Please go for 2-3 minutes, sir.
Okay. See, the physics that we have been discussing so far, this has been the standard theoretical model of physics on the basis of quantum mechanics and the standard model. And we have been very precisely following this. This has come because of the scientific methods, especially the practical necessity and the very basic motivation of Western science that one has to learn the discipline. So we have divided the nature into different disciplines. As a result, we understand only one aspect of the nature. Now, as we know that nature is unified, and as we are moving in the 21st centuries, the challenges are also non-adaptive nature, complex nature, and therefore one discipline is not able to tackle the problem completely. Therefore, the multidisciplinary environment has to be created, and in this environment, the role of physics becomes very important. It becomes very central because we need to develop a holistic science which is to be developed by templating nature. Now, as our knowledge of nature grows, it becomes necessarily, increasingly necessary to go beyond these borders and unite discipline. Physics can do this role very precisely because it has been at the center of developing various sciences. Only thing, as they grow, they have disconnected. Now we have to make this connect, and we don't have time. Otherwise, how this connect can be made, we would have discussed today. We have to inculcate in the material and energy framework of physics the information framework, 5 levels, and once we integrate it, the nature of universe, it becomes like this. The cosmos is reflected not only in 2 ways. Now in the 21st century, we have to understand that cosmos is reflected in terms of 3 ways: material, energy, and information. How to integrate the 3 and how to make a complex system so that it reflects the real reality, not the observed reality. And for this, people have already developed what is known as the block universe, where the past, present, and future of time are the 3 scales. The fourth scale is space. In this, the flow of information, the evolutionary nature of the universe, to which already this evolution of universe has been defined, and it has been considered as a progressive unfolding of information from micro scale to macro scale. And in terms of this, now complete Big Bang has been explained. People are now explaining how the life emerged using this framework, and where neither matter nor energy rather the information is central, which almost reflecting the Punarjan theory or the Pralay theory of Indian mythology. We are very close to it, very, very close to it. Thanks for listening. Any feedback is welcome. We had three very important technical application of quantum mechanics at present, but I have suppressed them. One is quantum computing, second is quantum communication, and third is the quantum cryptography or new encryption scheme. I was told that tomorrow somebody is going to give a talk on that, and therefore I have stopped that. But these are one of the three of the most important areas where practical quantum applications of 21st century are being competed by one of the most of the giants of the world. Thank you very much.
Thank you, sir. Vijay, sir?
Should I stop it?
Yes, sir. Vijay, sir, now. Participants are requested to ask
Himanshu, connect sir, na?
Yes, I am here. Anyone wants to have some query or some correction, some feedback, anything?
Yeah, I have a, you have taken us on a fascinating journey of the quantum world, and I think it was both in its simplicity and sophistication. It was a wonderful talk. So first of all, thank you, Professor Vajpayee. I had one question that is related to the accelerator you were talking about, that the one which became operational yesterday or a few days ago. Now, is this accelerator for studying particle physics or solid state materials, or what is going to be the role of this accelerator? Could you please explain it to us? Yes.
Actually, this is a 3 megavolt particle accelerator based on the tandem model of accelerators. So it's a tandem accelerator. The basic idea of this accelerator is to complement the National Accelerator Center, IUAC in Delhi, which has a 15 million volt accelerator, but the current of that accelerator is in the nanoampere. So for certain types of experiments, we need a very long time of exposure, and that is not available because that is the only accelerator in Delhi. So when we were designing this accelerator in 2009, the basic idea under the leadership of then director of IUAC and some of the scientists of VIJAY, TFR and SINP, we developed this as the highest current accelerator of the country. So it has the current, say for example, 6 MeV proton is available in this accelerator at around 6 microampere. So a current from nanoampere up to the microampere means there is a drastic reduction of radiation time. Not only this, the energy range in which this accelerator operates is such that it is intentionally designed so that the electronic stopping and the nuclear stopping both are active. Most of the experiments that are done in India so far, they avoid the nuclear stopping. The range of energy chosen shows the most of the energy of the beam, it is going into the electronic modes. And therefore, the interpretation of the results becomes simple. But recently, the simultaneous effect of electronic stopping in terms of the excitation and nuclear stopping in terms of the randomization of the structure, it has produced some marvelous results. Unfortunately, in the country, there was no accelerator where such range of energy was available, where both these effects can be studied. So this is the accelerator where electronic and nuclear stopping can be simultaneously studied. And the third important thing of this accelerator is that the proton at high current that is available will be used for generating the neutron. So the neutron activation work that are required for modeling the new technology nuclear installations, the material for that, like we studied the plasma ball, the Nobel alloy, development of Nobel alloy for the plasma ball to sustain the highest temperature that is generated. That was done in collaboration with the Ahmedabad IUAC, and we few years back we have developed a wonderful. So it was working. This accelerator is not that it has started working. It was working, but because of certain non-compliance of AERB, they stopped the experiment. So yesterday they have given the permission to start the experiment again. This is a national facility. It's a joint accelerator of IUAC and Guru Ghasidas University under the MOU with UGC. The maintenance of this accelerator is done by the IUAC, and the accelerator is run by the Faculty of Physics Department at Guru Ghasidas University. I had a little contribution that I conceived this whole program and developed this accelerator. We started in 2009, and the first beam we got in 2014. We did a lot of experiments from the whole nation up to 2018. But from 2018, this accelerator was not working. So it's a great news that one new accelerator is now started working. That's all. And it has many nice ideas, like it has the beam analysis chamber where you can do the PIXI, you can do the NRA, you can do the channeling, you can do many kinds of material science experiments. We also have the ion implantation facility, we have the irradiation facility, and most of it, this accelerator is run by the teachers. And therefore, there is a lot of opportunities of discussing and developing the new experimental design. And it also has a simultaneously nuclear physics complete setup with the HPG detectors and complete software electronic processing system. So people can also do very good nuclear physics experiments there.
Thank you. I think, do other people have anything? There are so many questions that may have come up. Yes. Himanshu, you'll have to organize this because I cannot see the chat. So
Yeah, I don't find any chat into this.
anybody who has a question can put it on chat. I can see the chat right now. Okay. Or anybody who would like to comment, if not just a question, if you'd like to comment. और कोई?
Santosh sir wants to say something.
सुनाई नहीं दे रहा है.
Yes, sir, please.
Please. Does anybody? आप लोग घबराइए नहीं, पूछिए. No, you should be free to ask, particularly students. Anyway, मुझे भी एक बात आपसे और पूछनी थी, कोई पूछ नहीं रहा है तो. I have so many questions, but one is an observation. This is not a question. The Higgs boson was discovered 50 years after the prediction, Professor BAJPAYEE. तो हम तो ये कहेंगे कि जैसे कि Bose condensation की जो बात होती है, that was predicted around 1925, and then it was observed only 70 years later. So some of these observations require a lot of work and have a very long time frame. So I just thought it was an interesting observation.
Yeah, that is true. That is true.
I was surprised to see that quantum this quantum observations idea, if you put for 12 points onto that. So you said the quantum observations.
Quantum?
It was the last
Quantum leadership.
Quantum leadership.
Yeah. It's a wonderful field coming up very progressively, and people are developing you see, adaptive models are the mathematical modeling which is done by using the complex interactions in terms of the parameters that I have shown. So you can take the parameters, associate some applied mathematics person who can do the modeling, and just take the non-linearity as you want, go on increasing, because non-linearity solving in mathematical models is a difficult thing. So you need some very good computational system. We have now many grids, supercomputers where this work can be done. So this is a very challenging field and very new field, especially for India, where we celebrate our diversity. And more diversity means more complexity, more interaction. So even the social behavior prediction and its outcomes, once they come up, then physics again gains the central stage. This is the whole idea, that the utility of physical models, utility of physics concept, especially the quantum physics concept, once it goes into the social sector, in the human behavior, in the organizational structure, then the physics gets rejuvenated. So this is the time when we can rejuvenate the application of physics in applied field and in the social sector.
Social behavior.
Sir, I have a question.
Sure, sir.
Sir, quantum entanglement, if characteristic of one particle is your changed, or immediately, I mean, as you simply told, in the very less time, rather the velocity is very high for the complications for the filling of the other particles. Is this very velocity is the very much comparable to the velocity of light, or what type of the velocity of the communication between these two particles?
See, photons have the velocity of light.
Yeah.
That is not the problem. The problem is the quantum entanglement. Like, say, for example, we have the classical communication channel of optical fibers.
Yeah.
In optical fibers also, if the mode of light that we fill, it travels few hundred kilometers, it get degraded because the various kinds of perturbation that are there in the optical fibers. And as a result, we have to have the optical amplifiers to amplify them. So this quantum entangled particles, when they travel, they get lot of noise. The noise in terms of temperature, the noise in terms of interactions, the noise in terms of interparticle. So we have to develop the technology how to maintain this entanglement. The problem with the quantum communication, I have not discussed the quantum communication, but entanglement, when we use either for communication or for computation, it has the wonderful thing that the communication or computation is completely secure, because the moment entanglement goes, the property relation goes, the information goes. But the problem is, if we want to have a stable quantum communication system, how to make it stable entangled. ये entanglement टूट जाता है जैसे ही नॉइज आती है, जैसे ही इंटरेक्शन आता है. अभी जो रिसेंट एक्सपेरिमेंट हुआ चाइना का और वियना के बीच में, लगभग 7000 किलोमीटर की डिस्टेंस में उन्होंने लगभग कई मिनट तक वीडियो कॉन्फ्रेंसिंग की based on the quantum entanglement. But the problem is it was a secure system, and the cable is the satellite, the space vacuum. That is the best cable for quantum communication. The whole problem is how to send the entangled state from receiver to the satellite. So most of the quantum computation and quantum communication experiments are how to sustain the noise in the entangled environment.
So we think so, sir, कि आने वाले समय में in coming years, if we are going to reduce these perturbations and rectify these noises and etc., it will be very much helpful in the communication field.
अरे ऑलरेडी आप देखिए नासा डेनमार्क के क्वांटम कंप्यूटर्स ऑलरेडी यूज कर रहा है.
जी सर.
और अभी मुझे मतलब मैं कंफर्म नहीं हूं, बट आई वाज टोल्ड बाय समवन दैट IBM हैज आल्सो परचेज. They have announced the quantum computers already crossing the classical computers limit.
Okay, sir. Thank you, sir. Thank you very much.
Vijay sir?
Yes. Okay, so if there are no further questions, let us thank the speaker, Professor Pramendra Vajpayee ji. बहुत सुंदर लेक्चर आपने दिया और बहुत बहुत धन्यवाद आपको.
Thank you so much, sir.
Thank you very much, sir. Thank you very much.
Amren sir is also there.
अमरेंद्र जी, आप कुछ कहना चाहेंगे? अमरेंद्र जी नहीं, कुछ दिख भी नहीं रहा है आज अभी. अच्छा.
Oh, sorry. So, no, the lecture was very, very interesting. और बहुत मतलब very informative, sir. Thank you.
Thank you so much. Thank you. Sir, should I take leave now?
Yes, sir, please.
Thank you.
You can take it.
Thank you very much, sir. Thank you very much.
थैंक यू हिमांशु, बहुत मेहनत की आप लोग.
Thank you.
प्रणाम सर विजय सर. प्रणाम सर प्रमेंद्र.
आपको भी प्रणाम.
जी सर.
प्रमेंद्र जी,
बहुत बढ़िया, आपको डेली देखने का मौका मिल जा रहा है. थैंक यू वेरी मच सर.
थैंक यू.
कल का भी लेक्चर इसी टाइम से है.
कल किसका भी लेक्चर है?
उत्पल राय जी का.
कितने? 5:30 बजे?
5:30 बजे.
चलिए कल मिलते हैं हम लोग. ओके, थैंक यू.
ओके.